Hello everyone, a very happy evening. So I'm really happy to welcome you all to the day 6 of refresher course. So today our session is related to mathematics. So in today's session, Dr. Ramesh Babu sir will be covering the topic integration using trigonometric identities. And just to brief about sir, he is currently working as assistant professor in the Department of Mathematics, Amrita School of Physical Sciences in our Ittimadai campus. The Amrita Vishwavidyapitham campus in the Ittimadai. He has completed his MSc Mathematics and PhD in Mathematics from Bharatidasan University. And he is acting as a reviewer. He has been in different editorial boards and board of studies member. He has been working with applied mathematics and computing, acting as a reviewer for the applied mathematics and computing for the Springer. So I'm really happy to welcome sir towards today's session. So students, please kindly note, if you're having any queries, you can type that queries in the chat box and sir will be addressing those queries. And I could see some students were asking for the materials of the session. I know you have been asking the materials of all the sessions that we have conducted. So with the video, I have promised that we'll be mailing you the videos of all the sessions of the refresher course. So in that same email, I'll just provide a link where you can download all these, I would say the slides or the PDFs that we have used during the session.
Good evening, children. I really appreciate your interest on understanding best possible way in integration by using trigonometrical identities. In usually, trigonometrical identities may be used in a simplification of the very complex terms. For example, it's in the Cartesian coordinates. I want to substitute by the parametric form like a cos theta, a sin theta, or a tan theta, and b secant theta, and all. By this way, we can also use these trigonometrical identities to simplify, to evaluate the integral in the best possible way. So in this session, I will do this uh, integration by using trigonometrical identities. Now I am sharing my, is it visible?
Yes, sir. Yes, sir. It's visible.
Yeah, 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 yeah. So topic is about integrals using trigonometrical identities. My plan is, first of all, I want to introduce some basic trigonometrical identities, and also we can use these trigonometrical identities to solve some problems, some integral, definite integral and indefinite integral problems. Mostly I concern with the indefinite integral. First of all, I want to make sure about some integration is given. That integration is having three components. One is integral sign, another one is integrand, another one is dummy variable. There are three important components. So I want to simplify the integrand by using this trigonometrical identities. That's what I'm going to do. So the first I want to introduce the Pythagorean identities. The first identity, everyone knows that sine and cos, the relation between cosine and cos, we can write down sine squared theta plus cos squared theta is equal to 1. Or sometimes people will write down sine squared theta is nothing but 1 minus cos squared theta. Instead of theta, just I am putting here x. That's all. Or otherwise, we can write down it as cos squared theta is nothing but 1 minus sine squared theta. So by this way, I can give a first identity. The second identity is secant squared theta minus tan squared theta is equal to 1. You know very well, secant is nothing but 1 by cos, and tan is nothing but sine by cos. If you want to substitute, you can elaborate, you can expand it. Secant as 1 by cos and tan is sine by cos. Then again, you can get right hand side is equal to 1. So I can come into that I can derive this second identity as secant square theta minus tan square theta is equal to 1. In similar way, I am connecting with the cosecant and the cot. How I am connecting is very interesting. This in these all these identities can be derived from a triangle, right? So x is a angle in this some one of the triangle. We can derive this cosecant square theta minus cot square theta is equal to 1. So there are some other identities. Is also that there are many identities. I can elaborate. I can list it out one by one once I am solving the problems. Okay. Now I'll move to the next identity set of identities, even and odd identities. What do we mean by even and odd identities? Sin x is a odd function, everyone knows, and cos is a even function. If you are replacing x by minus x, your the minus sign will be coming out from the sign. That is sine of minus theta is equal to minus sin theta, like this. And sorry, and a similar way, the cos of minus theta is equal to cos theta. Therefore, sine and cos are first one is an odd function, second one is an even function. Again, you can ask me another identity. What is tan of minus x? So tan of minus x is nothing but minus tan x. And a similar way, I can say that secant of minus x will become secant x. Cosecant of minus x will become minus cosecant x. So we can derive all other identities. So these identities are usually call it we called even and odd identities. I'll go to the next one. Another identities I want to introduce here is sine, cos, tan of sum and difference of identities. Sine of x plus y is equal to sine x cos y plus cos x sin y. And similar way, sine of x minus y is equal to sine x cos y minus cos x sin y. Sometimes people are saying that sine of a plus b or sine of alpha plus beta. It doesn't matter. After all, it's an angle. X and y are angles. In similar way, cos of x plus y can be written as cos x cos y minus sin x sin y. And similarly, cos of x minus y is equal to cos x cos y plus sin x sin y. That's why I'm taken up here, um, not plus or minus, minus plus, plus or not plus or minus is here minus or plus. In similar way, tan of x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. And tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x tan y. So I combine these two formulas in a single entity. Right? Shall I go to the next one? Next identity? Is it
Uh,
okay?
yes, sir. If there are any queries, they'll be typing that in the chat box.
Yeah. Then only I can.
Yeah.
Yeah, fine. So I'll go to the another identity. This identity is called double angle identity. Why it is called double angle identity? After all, what I am doing here, twice the angle. So sine of twice the angle gives you 2 times of sine of this angle and cos of this angle. That means sine 2 theta is equal to 2 sine theta cos theta, or sine 2x is equal to 2 sine x cos x. And again I am taken up cosine of cosine of double the angle. Cosine of double the angle is nothing but cos square theta minus sin square theta. That is one identity. Another identity, we can substitute sin square theta is equal to 1 minus cos square theta. We are getting 2 cos square theta minus 1. If you are replacing cos square theta here in the second identity, cos square theta is equal to 1 minus sine squared theta, I am getting 1 minus 2 sine squared theta. So cos 2 theta having three identities. One is cos squared theta minus sine squared theta. The second one is 2 cos squared theta minus 1. And the last one is 1 minus 2 sine squared theta. And similarly, I can give you another identity, another for tan of the double angle identity. That is tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta. Actually, what I am doing, I am applying the previous one. See this tan of x plus y replacing y is equal to x. Then what happened? You are getting all these results, right? So by this way, I am getting this all the double angle identities. Now I'll move to this triple angle identities. What is this triple angle identity? Sine
Sir,
3x can be written as, yeah,
hello, sir.
yes,
It's like students are just typing. The identities of the formula is written towards the end is not showing. So can you please just scroll down?
oh, is it okay?
No, I think it's a PDF, right? So we can just scroll down. Mm,
I think it is fine.
mm. No, but here in this case also we are not able to see the last identity that is written there. This way
Okay,
I
is it
think it's
okay?
better. This way it's better, sir.
This way it is better. Okay, okay, fine, ma'am, fine, fine. Yeah. So these are nothing but sum and difference of identities which you have seen. Another set of identity is a double angle identity. So in this identity, I am having all this sine 2 theta is equal to uh, 2 sine theta cos theta, right? And similarly, I can have another identity cos 2 theta is equal to this is one formula, one identity. This is one identity, and this is another identity, second identity, and this is the third identity, right? So this cos 2 theta having a three kinds of identities, and after this tan 2 theta is having 2 tan theta by 1 minus tan squared theta. Okay, shall I go for the next one, triple
Uh,
angle identity?
uh, Actually, somebody has raised their hand.
Ah,
So if there is any query, can you please type it in the chat box? So I think, sir, now what are your underlining? It's showing, sir.
yeah, it's showing, huh?
Yeah,
Okay, that's why that at least I have to do write something, right?
yeah. And now it's showing, sir. Sir, we can continue.
Okay, okay, fine. So I'll go for the triple angle identity. The triple angle identities are sine 3 theta is equal to 3 sine theta minus 4 sine cube theta, or sine 3x is equal to 3 sine x minus 4 sine cube x. And this is a three times of this angle. This is a three times of this angle. And this is nothing but three times of sine of one angle minus 4 sine cube x. So, and the second identity is cos of three times of this angle can be written as 4 cos cube x minus 3 cos x. So see the difference between these two identities. And similar way, tan 3x is nothing but 3 tan x minus tan cube x divided by 1 minus 3 tan squared x. All these are three identities are based on triple angle identities. Triple angle identities. Okay. Shall I go for the next one?
Yes, sir. Yes,
Able to
sir.
understand this? Yeah, fine.
So students, please note, if you're having any queries, you have to type that in the chat box. Then only sir will be able to answer it.
So this one is a sum to product of two angles. So there are two angles here, x and y are two angles. I want to sum it up, these two angles, sine of x plus sine of y. That can be written as 2 times of, that is nothing but 2 times of uh, sine of x plus y by 2 cos of x minus y by 2, right? Okay. So this first one can be taken up from sine of x plus y and cos of x minus y. So you can apply this formula. You can get it the previous, from the previous identity. I can write down sine x plus sine y is equal to 2 times of sine of x plus y by 2 cos of x minus y by 2. In similar way, sine x minus sine y is nothing but, we can taken up this as 2 times of cos of x plus y by 2 and sine of x minus y by 2. So the first two identities in this slides are representing sum to product of two angles of sine. Here, the third and the fourth identities are, interestingly, this cos of x plus cos of y, that is sum to the product of two angles with respect to the cosine. So cos x plus cos y, cos x plus cos y is equal to 2 times of cos of x plus y by 2 cos of x minus y by 2. In the right hand side, the product is both cos when it comes in plus sign. If it is minus sign, we are having both are minus, both are sign, but having minus sign. So that is the only difference. You can see the difference very well. Okay. You have any query on this? Any questions you want to ask you can put in the chat box and I will. Okay. Shall I go to the next slide? Hmm?
Yes, sir, we can move forward.
Another one is, previously we are seeing sum to product. Here, product to sum of the two angles. For example, I am taken up the product to the sum. Sin x sin y can be written as the difference between cos of x minus y minus cos of x plus y by 2. And cos x cos y will become cos of x minus y plus cos of x plus y by 2. And similar way, sin x cos y can be written as sin of x plus y plus sin of x minus y whole divided by 2. So the first one is a product. This is my product. Okay, this is a product. Okay, but the right hand side is a kind of sum. Okay, this is sum. And a similar way, this cos x cos y is nothing but cos of x minus y plus cos of x plus y by 2. And similarly, this sin x cos y can same as sin of x plus y plus sin of x minus y by 2. And cos of cos x cosine y will become sin of x plus y minus sin of x minus y by 2. So these formulas, all these formulas can be derived from this formulas. This one. Replacing simply x plus y by 2 is equal to c and x minus y is by 2 is equal to d, you are getting these formulas. These two slides are interconnected. Interconnected. Okay. You have any question on it? Madam, anyone is raising a hand? Please let me know.
No,
Then.
sir, no, sir.
Okay. Shall I go to the problems
Yes,
right
sir,
now?
we can start the problems.
Yeah, fine. Fantastic. So the question is this. The first question is indefinite integral. The integral is having tan and the secant. The first one is I am getting tan power 4, tan power 4 root x and the secant squared root x by root x. See, there is one thing common here because root x is common in this integration sign. Root x is there. And there is a product in the numerator, tan power 4 into root x into secant squared root x. And denominator is root x. So I want to give a proper trigonometrical substitution. and make this integrand. You know what is integrand? This is called integrand. You have any questions, please ask me. Right, this is integrand. This is my integrand. Okay, so I want to integrate this one. X is called a dummy variable, so I want to give a proper substitution here. What is my substitution? My substitution here is u is equal to tan of root x. That is my substitution. So when you are taken up the substitution, okay, when you are taken up the substitution, u is equal to tan of root x, I have to differentiate on both sides. So you know very well, differentiation of tan x is secant squared x. But instead of that, this tan x, I am having tan of root x. So if you are differentiating tan of root x, I am getting secant squared root x. Again, I have to differentiate root x, that is 1 by 2 root x is equal to, when you are differentiating u, you are getting du by dx. Now, I comfortably cross multiply this dx to this term. So what happened here? What happened here? Secant square root x by root x is replaced. I can write down here. This term. Would you able to see this? This term is replaced by du. This term is replaced by two types of d. Two types of d. Okay. So 2 times of du, and tan of root of x is nothing but u power 4, because tan power 4 is that. Therefore, I am getting u power 4. Do you have any questions right now? You want to ask this any questions? Madam, if anyone is raising a hand, please let me know.
Dear students, if you want to talk with sir, uh, okay. So I think maybe so we can take the questions towards the end of the session.
Okay,
Okay.
fine, ma'am. Fine.
Yeah.
Okay. So integral of 2 times of du, I am taken up 2 common. This is u power 4 into du. So you know the very well about integration of u power 4 into du is nothing but u power 5 by 5. Applying the formula u power n plus 1 by n plus 1. 4 plus 1 is 5. So u power 5 by 5. But again, you have to resubstitute, back substitute u is equal to tan of root x. Therefore, u is equal to tan of root x, then 2 times of tan power 5 root x by 5 plus c. The c is nothing but integral constant. Even though the problem seems to be very hard in the first sight, you have to understand that you have to give a proper trigonometrical substitution here. So what is a connection, sir? Connection is very simple. Differentiation of tan is secant squared x. That is my connection. So you have to identify the connection. That's very important, right? So in this problem, I am having the connection that I am giving a substitution u is equal to tan of root x, and connection is that differentiation of tan is secant squared x. That's all. Shall I go for the next problem? Yes.
Yes, sir.
Okay, fine. This is my second problem. Okay. In this problem, we are having integration over sine of tan inverse of x by 1 plus x square into dx. Right? This is actually uh, second problem. Right? This is my second problem. So sine of tan inverse of x by 1 plus x square. So see the technique here. What is the connection between the trigonometrical function sin tan inverse of x and 1 plus x squared? Differentiation of tan inverse of x is 1 by 1 plus x squared. So 1 plus x squared is in the denominator. Therefore, I am giving a substitution u is equal to tan inverse of x. So try to understand here the connection between tan inverse of x and 1 by 1 plus x squared. So, so that the substitution must be u is equal to tan inverse of x. So what will be this du by dx? 1 over 1 plus x squared into dx is equal to du. So I can write down here, 1 over 1 plus x squared into dx is equal to du. So when you are taken up the substitution u is equal to tan inverse of x, I am getting here sine u. I think the dx is missing here. This here, okay. So dx by 1 into dx by 1 plus x squared is nothing but du. Therefore, integration of sine u is nothing but, you know very well, minus cos. Integration of sine u into du is minus cos u. Again, I substitute here u is equal to tan inverse of x. So what I am getting here is minus cos of tan inverse of x plus c. So in this problem, the connection between tan inverse of x and 1 over 1 plus x squared is very important. So need the in working out the problems, you are always having some, not only a trigonometrical function but also some rational functions. 1 over 1 plus x squared is a rational function, right? So you have any question on this problem? Shall I go for the next problem?
Yes, sir.
Okay,
Sir,
fine.
actually, I think Kamalesh is asking some question. I'll just give him permission to talk.
Yeah,
So
sure, sure.
Kamalesh, just a second.
Yeah, sure, sure.
I've given you permission to talk. Actually, he's asking for first question answer. I think
First question. I
answer.
am not. First question answer is here. 2 times of tan power 5 root x by 5 plus c.
I hope you have checked it. If those students will be sharing the recording, so there is no need to worry on this. So yes, sir, we can continue. Thank you, sir.
Okay. So see the compare the difference between the first problem and second problem. First problem is completely I am depending upon the derivative of this tan x. That's why I'm taken up a substitution brilliantly. U is equal to tan of root x. But here in the second problem, I'm taken up u is equal to tan inverse of x, whose derivative is 1 over 1 plus x square. So that is a connection. So you have to understand the connection between these two. That's very important. So I'll move to the next problem. This problem is the combination of sine cube x and cos squared x into dx. See, sine and cos. So one can understand that sine cube x can be written as sine squared x into sine x. For example, x cube can be written as x squared into x. In similar way, sine cube x can be written as sine squared x into sine x. But sine squared x can be written as 1 minus cos squared x. Actually, this is your sine squared x. We know the identity. Sine squared x is nothing but 1 minus cos squared x. So I am applying this identity. See what happened here. Again, I am taken up sine cube x into cos squared x into dx. I want to replace sine cube x is nothing but 1 minus cos squared x into sine x. So I multiplied with the cos squared x into dx. So first term is 1 into sine x, sine x into cos squared x is here. The middle term is minus sign is there. I put it in minus term. After all, this is nothing but cos squared x into sin x. Already cos squared x is here. So sin x into cos power 4x into dx. So why you are doing like this? That's a question you can really ask him. If the trigonometrical function is coming, what I am expecting is at least one of the sine or cos or tan, whatever it may be, I should have a power 1, right? The power must be 1. So that's why in this first term, in this term, to be able to see this, there are sine term is there, cos term is there, but sine term power is 1. And also here also sine and cos are there, but sine power is 1. So what's the purpose there? Very simple. If you are taking up u is equal to cos x, differentiation of cos x is nothing but minus sin x, right? Differentiation of cos x is minus sin x. So sine term will be there. So the idea behind it, to splitting this sine cube x into sine squared x into sin x is, this is the reason. I am getting only one sine. The rest of the thing I convert into cos. Got a point? Have any questions? I am having sine cube x. Sine cube x can be written as sine squared x into sin x. But sine squared x can be written as 1 minus cos squared x here. 1 minus cos squared. Again, I multiplied with sin x minus cos squared x into sin x. Just I substitute in this sine cube x by this term and split it into the two terms. Therefore, here I substitute u is equal to cos x. If u is equal to cos x, what happened? You have to do it. U is equal to cos x, du is what? Minus sin x into dx. So I am getting minus u squared into dx. Minus u squared into, what is the integration of u squared? U cube by 3. That's why I am getting cos cube x by 3. Similar way, here also minus u power 4 into dx. Minus into minus plus taken away. What is u power 4 into dx? U power 5 by 5. That u power 5 by 5 gives you this cos power 5x by 5. Once again I repeat this term, because I am not write down everything in this slides. What I'm expecting is you're also working on it. You're also understanding this, right? I'm not explicitly showing everything. I'm giving a hint at every steps. So what I am doing here is substituting u is equal to cos x. The first term will become minus integration of u square into dx. And similar way, the second, so again the middle term is minus, taken away minus into minus x, u power 5 by 5. Substituting again u is equal to cos x, cos power 5x by 5. And what is here in the first term? Integration of minus u square into dx, taken away minus sign. What is integration of u square into dx? U cube by 3. What is u? Cos x. Substituting here, cos cube x by 3. So the answer for this problem is minus cos cube x by 3 plus cos power 5x by 5 plus c. So the brilliant idea in this problem, you have to convert into the trigonometrical functions. At least one function, the whole power must be 1. Then only I can diligently give you substitution u is equal to cos x. I think, I hope, shall I go for the next problem?
Yes, sir. I think as of now, we don't have any queries for the problems that we have solved.
Okay. Everyone should work it out and check the answer as well. I am giving an idea about how it can be done. What is the reason behind it? For everything, there should be a reason, right? You are solving the problem, there is some reason behind it. That reason should be recreated every time. Okay. Okay, fine. So I'll do the next problem. Next problem is integration over, both are sine. There are rational functions. In numerator it is also sine, and denominator also sine. The problem here is, I am having a uh, x sin x by sin of x plus a. A is some constant. A is some constant. But the question is, we cannot integrate as it is. That is a problem. So what should I do? I have to give a substitution. So what is my substitution here? The substitution here is x plus a is equal to t. Sir, x plus a is equal to t. Then what is the value of x, sir? T minus a. If x plus a is equal to t, I can write down x is equal to x is equal to t minus a. So I want to give a substitution in this integral. What happened here is sine of substituting x is nothing but t minus a, substitute here, and x plus a is equal to t sine t. What is dx, sir? When you are differentiating on both sides, I am getting dx plus a is there, so it will become 0 is equal to dt. So dx is same as dt, not a problem. In the substitution, dx is equal to dt. So I am changing the dummy variable x into t. That is an idea. And after that, I am applying the sine of a minus b formula, sine of x minus y. Sine of x minus y is equal to sine x cos y minus cos x sine y. So x is equal to t and y is equal to a. Just I am substituting here. You got it? In this term, I can split into the two terms because the numerator is having two terms, denominator is a single term, sin t into cos a by sin t gets cancelled, minus cos t into sin a by sin t. So cos t by sin t will become cot t, right? Cos t by sin t is cot t into sin a, right? So here I can taken away cos a outside, integration of, right? Sin t gets cancelled. So I am taken away this only cos a is there. So integration of cos a into dt minus sin a is taken out minus integration of cot t into dt. So in the first term, what happened? I think here integration of cos a is a constant outside. Integration of dt is t, right? Integration of dt is t. So what happened here is I think this term should be x plus a. This is t times of, I can write down here, integration of dt is t into cos a. So t is equal to x plus a. Therefore, cos a into x plus a. I think cos a something like there is some mistake. Cos a into x plus a. That should be written cos a into x plus a. And second term is sin a is taken away. Integration of cot a is nothing but ln of sine of t. But t is nothing but x plus a. I substitute here x plus a. Therefore, I am getting ln of sine of x plus a. A last step to be able to understand. If you have any queries, you can ask me, because sin t gets cancelled, cos a is there, cos a is taken out, and integration of dt, 1 into dt is dt, integration of dt is t. But t is nothing but what? X plus a. That's why I'm write down this x plus a into cos a. Into cos a. The first term is x plus a into cos a. Or sometimes you can write cos a into x plus a. Both are same. Minus, here sin a is a constant taken out. Here cos t by sin t is nothing but ln of sine of sin t. So t is nothing but x plus a. So I am getting this answer. So the final answer is this: cos a into x plus a minus sin a into ln of sine of x plus a plus c. So this problem is somewhat very interesting problem. Even though the sine term is there, I am not using directly the identity, but I am using it sine of x minus y inside. Even though the initial substitution is not a trigonometrical identity. Shall I go to the next problem? Shall I go to the next problem?
Yes, sir.
Okay. So in the previous problems, what's the difference between this problem and the previous problems? The previous problems, all the substitutions, initially I'm giving some trigonometrical substitution. But in this problem, I am giving an algebraic substitution, x plus a is equal to t. After that, inside this integral, I am using the identity, trigonometrical identity. That's an idea. Okay, fine. I'll go to the next problem. Yeah, this is everything. It's a simple problem, but I have to identify this identity carefully. So I want to integrate cos squared x into dx. What is cos squared x? I know the identity. Cos 2x is equal to 2 cos squared x minus 1. That identity I don't know. So how can I get it cos squared x, sir? Cos squared x can be written as 1 plus cos 2x by 2. So I can use this identity. I can use this identity. I can use this identity so that from this I can write down this minus 1 to the left hand side. So minus 1 will become plus 1. Therefore 1 plus cos 2x and multiplied by divided by 2, cross multiply this 2 divided by 2. Therefore 1 plus cos 2x by 2 is nothing but cos squared x. So I'm applying here in this integration symbol that cos squared x, integration of cos squared x can be written as integration of cos 2x plus 1 by 2. I can divide it by 2 separately, cos 2x by 2 plus 1 by 2. So when you are splitting it, integration of cos 2x by 2, 1 by 2 is taken out. So integration of cos 2x will become sin 2x divided by 2. That 2 into 2 is 4. Again, 1 by 2 is already there. That when you are integrating it, you are getting 1, 2. So 2 2s are 4. So sin 2x by 4 plus. Now the middle we are having plus. I am putting here plus. So here 1 by 2 only. Integration of the x is x. 1 by 2 into x is x or x by 2. So I am putting here x by 2 here. So this is a very simplest problem. I am not using a big identity here, but even though once you understand this trigonometrical identity, how to substitute, when to substitute, where to substitute, and you can easily get the results. So this is one of the very simplest problem among all the problems. All right. Shall I go to the next problem?
Yes, sir.
Have any question? No questions so far, right?
No question so far.
Okay, I'll go to the next problem. Mm, yeah, I think this problem is having not as power is not having a different power. It's only one power. Is both the powers are same, sin 2x and cos 3x. But these are the product of sine and cos. I have to using the product to sum rule. You recall the rule, product to sum rule. That is sin 2x cos 3x is nothing but sine of 2x plus 3x minus sorry plus sine of 2x minus 3x. You recall this function? I am applying the formula. This formula is sin A sin B. Sin A sin B is nothing but sine of A plus B plus sine of A minus B. I think A minus B is here, it is hidden somewhat. It must be like this is A minus B, right? So I am applying the formula here. A is nothing but 2x, B is nothing but 3x. Substituting here, 2x plus 3x is 5x, and 2x minus 3x is minus x. But applying the formula, Sine of minus x is equal to minus sine x. So where I am substituting in this term, sine here, so already plus is there, so plus into minus minus, so sine 5x minus sine x by 2. So sine 2x into cos 3x can be rewritten as sine 5x minus sine x by 2. So I am substituting here and the integral sign. So integral sign, what happened? I can take up 1 by 2 common. Integration of sine 5x is minus cos 5x by 5, and integration of sine x is minus cos x. So minus into minus plus here. So here minus sign is there. Already 2 is there. 2 5s are 10. So minus cos 5x by 10. So I am applying two identities. First identity is sin A cos B is sin of A plus B plus sin of A minus B. How the minus signs come? Because sine of minus x is there. Sine of minus x is minus sin x. So I put it here, already plus is there, plus into minus minus, minus sin x comes. So in this integral, I am using two identities. The first identity is sin A cos B, that is sin of A plus B plus sin of A minus B. And another identity is odd even identity, sine of minus x is equal to minus sine x. So once I am getting all this value, directly integrating this integration of sine 5x will become minus cos 5x by 5. 5 2s are 10. I am getting 10 here. Here, integration of sine x is minus cos x. Already minus sign is in the middle. So minus into minus plus cos x by 2 is already there. So plus c is an integral constant. So in this problem, I am not substituting anything. I am using the trigonometrical identity. I am not using the substitutions, but directly applying the trigonometrical identities. Okay. Shall I go to the next problem? Yes.
Yes, sir. I think there are no students have typed nothing as of now. So I think we'll just
Okay.
finish the session and then we'll check for the questions.
Yeah. Once I complete, then I'll go for
Okay,
whatever
sir.
I.
Okay. Okay.
Once I'll do one more problem, right?
Yes, sir.
So I am having integral of sine cube x into dx. Actually, integral of sine cube x, I know the triple angle identity. What does the triple angle identity says? Sine 3x is equal to 3 sine x minus 4 sine cube x. But here, the minus 4 sine cube x can be taken away in the left hand side. So what happened? 4 sine cube x is equal to 3 sine x, and sine 3x will become a term, bring to that right hand side. So it will become plus, will become minus. Therefore, 3 sine x minus sine 3x, and divided by 4, I am getting sine cube x. So sine cube x formula here, identity is 3 sine x minus sine 3x divided by 4. After all, 1 by 4 is a constant taken away. So 3 times of sine x will become, integral of sine x will become minus cos x. So minus 3 by 4 times of cos x. See, what I am getting here is very interesting. See, I am applying the formula here. This formula. From this formula, I derive this identity. This identity, right? So sine cube x is nothing but 3 sine x minus sine 3x by 4. After that, I am taking integration as usual. But the first integral of this first term is nothing but second one, minus 3 cos x by 4. Here, integration of sine 3x will become minus cos 3x by 3. So minus into minus plus. That's why I'm putting the first term. Usually we have done it. Whatever the results we are having in the putting in the positive term first, negative term second. So in that way, I am getting cos 3x by 3. Already 4 is there. 3 4s are 12. So cos 3x by 12 is there. So cos 3x by 12 minus 3 cos x by 4 plus c. In this problem, I am using a trigonometrical identity, but not using the trigonometrical substitution. I am not using the trigonometrical substitution. I am using only trigonometrical identity from the triple angle identity. Uh, okay, fine. I'll go to the. I hope you understand this problem. I think just I'll go for the next one. Next problem. This problem is having cos cube x and sin cube x and sin squared x into cos squared x. So this is quite interesting problem because we are having a numerator and denominator. Okay. In this numerator, we are having sin cube x plus cos cube x. Denominator is sin squared x into cos squared x. I can split it into the two terms: sin squared x by sin cube x by sin squared x into cos squared x plus cos cube x by sin squared x into cos squared x. So sin squared gets cancelled. I am getting only sin x by cos squared x. That is the first term. The second term, cos squared x cancel. I am getting cos x by sin squared x. So it's a very interesting problem because I am having sin x by cos squared x, but this can be written as directly. We can directly return sin by cos is tan, 1 by cos is secant. I can write down secant x tan x into dx. Integration of secant x tan x into dx. We can directly write down integration of secant x tan x is nothing but secant x. So even though I'm not doing any substitution here, I'm not doing any substitution. I'm only doing simplification. So the simplification of this term is very important. I bring into that two terms. Single term is transformed into two terms. That is an idea. I'm not using any trigonometrical identities. I'm using only formulas, integration formula. There is no trigonometrical identity I am using. I am not using the trigonometrical substitution. I am rearranging it. Sin by cos is tan, 1 by cos is secant. So integration of tan x into secant x into dx, that is what secant x. And integration of the second term is cos x by sin x into 1 by sin x. 1 by sin x is cosecant x, cos x by sin x is cot x. So cot x into cosecant x, integration of cot x into cosecant x into dx is nothing but minus cosecant x. So I am getting secant x minus cosecant x plus c. So it's also quite interesting. So the last problem, it is completely different from the previous problem. I am not using any identities. I am not using any trigonometrical substitution. What I am doing here is only simplification, right? Yes. So the last problem in this session, I am giving you a hint that you have to work on it. Here, tan cube 2x into secant 2x into dx, right? But tan cube 2x, I want to integrate this, all right? Integration of tan cube 2x into secant 2x into dx. But tan cube 2x can be split into tan squared 2x into tan 2x into secant 2x into dx. So you can take an up substitution. What is my substitution? U is equal to tan 2x. U is equal to tan 2x. You are getting this. Got it? You have any questions? Substitution is U is equal to tan 2x. Right? When you are doing it, then you are getting the solution. It is an exercise problem to you. So with this, I will complete my session. And if you have any questions, you can post to me, and I will answer it.
Okay. So, sir, I think Chandrakala has raised their hand. I have given you permission to talk also. Can you please directly
Yeah,
talk with sir?
yeah, sure.
I have given you permission to talk. Can you please talk? Sir, there is someone who has requested for Chandrakala. You can continue.
Yeah,
Okay.
please, Chandrakala. Hello, you can talk. What's
Okay,
your question?
completely fine. Sir, actually, somebody has requested for the kindly explain the last question again.
Okay, okay, fine. Yeah. See, the last question is integration of tan cube 2x into secant 2x into dx. Right? Clear. In this term, what I am splitting here is this alone, tan cube 2x. That can be split into tan square 2x into tan 2x. Or do you agree with me? Tan cube can be written as tan squared into tan, right? And again, substituting here, I will write down here substitution u is equal to u is equal to uh, tan 2x. So what happened du? You tell me. What is du? You tell me what is du. Tan 2x will become when you are differentiating it. What happened? U is equal to tan 2x, and you have to give a substitution. This is your substitution, man, no doubt. And moreover, very quite interesting point here is tan cube x 2x can be written as tan 2x into tan squared x, and substituting this, and you can it will reduce to in terms of u, right? Okay, okay. Someone is Hemalata. I think someone was asking questions, and I couldn't see here. Actually, I expect you to do it the problem, right?
Uh, Hello, sir.
There are some problems they are asking. I think, sir, could you explain me how to do this sum integration of
Okay, I'll just
sine
give him
x?
permission to talk, sir. Just a second.
Yes, yes,
I
yes.
think it's
Please, please, please.
Aditya. Aditya, I have given you permission to talk. So,
Yes, ma'am. Good evening, ma'am. Good evening, sir.
Yeah. Good evening, man. Good evening.
Sir, actually, while going through my textbook, I had one of this sum. So it is
Ah,
integration of sin x by 1 plus cos x plus sin x dx. So how
yeah.
could we do this?
So this can be done by a kind of because sine and cos is there, right?
Yes, sir. Sin x by 1
Okay.
plus
Wait.
cos x plus sin
Yeah.
x.
Wait. Taken up some r cos theta and r sin theta,
Okay, sir.
because you are having sin x by 1 plus cos x plus sin x.
Yes, sir.
Sin
In
x by
denominator, it
divided
is
by
1. Yeah. In denominator, it is 1 plus cos x plus sin x. Numerator is sin x.
yeah. So if it is like that, you can apply sin x is equal to 2 tan x by 2 divided by 1 plus tan squared x by 2, and cos x is nothing but 1 minus tan squared x by 2 by 1 plus tan squared x by 2.
Yes.
Once again I repeat it. You are having only sin x and cos x alone, right?
Yes, sir. Yeah.
So you substitute here, sin x is equal to 2 tan x by 2 divided by 1 plus tan squared x by 2. That is for sin x. For cos
Yeah.
x, 1 minus tan squared x by 2 divided by 1 plus, write down it.
Yes.
Sin x is equal to 2 tan x by 2. 2
2 tan
times
x
of
by 2.
tan of x by 2 divided by
Yes.
1 plus tan squared x by 2.
Yes, sir.
And cos x is equal to 1 minus
Yes, sir.
tan squared x by 2 divided by 1 plus tan squared x by 2, right?
Yes, yes, sir.
So it will simplify the problem easily. I think it's not a problem, big issue,
Yes, sir. Thank you.
right? Okay, fine.
So
I think anyone
students,
is having a
if there
questions.
are any further queries, I would help you to directly communicate with sir. You can just raise your hands or you can type something in the chat box so that I'll be able to help you. And dear children, don't worry about the recordings. We'll be uploading it in the same YouTube channel where we have uploaded the STEM search problem solving workshops. So this videos will be updated by, I think, after tomorrow's session, and then we will be sending you a mail with the whole recordings. And those students have asked for the slides. I'll also share the slides of all these sessions as of now in a link, and you can just download it from there. So yes, are there any students who are having further queries? Okay. So yes, I think, sir, we have covered almost all the queries. And students, please do join for the final day, day 7 of the refresher course. It's just going to be a general session where we'll be providing a platform where you can just um, tell any worries or anything that you're having, and we'll just help you with that. So please do attend tomorrow's session also. And thank you so much, dear children, for attending. Thank you so much, sir, for sparing this much time, and thank you so much for clearing all their doubts. So thank you, everyone. Thank you so much,
Thank
sir.
you. Thank you.
Have a good
Thank you.
evening,
Thank you.
children. Thank you all.